Hi again, it's me. This is part 2 of our notes today on 9/18/19. I am passing out, or you should have this paper. If you don't have this paper, you can stop the video right now and grab this paper. At this point, right at this moment, we're going to work on the right side where it says transformation guide. So we have talked about transformations. Transformations like I'm going to transform myself. I can transform myself through a haircut or makeup done or losing a bunch of weight or working out or whatever it might be. In math, there are different types of transformations. We talked about translations, which means movement. We've also talked about reflections. We talked about like mirror images. Hold on, let me try to balance my phone and do this. Mirror images. Okay. The other transformation that we have not talked about yet is a dilation. That's just like getting bigger or getting smaller. We often call these, I haven't actually said this yet, but stretch and shrink. And so we have talked about that, but I have not called it by the word dilation yet. Okay, so let's say you have something like this, and it works for absolute value as well. The parentheses don't necessarily need to be there. But if you have a function, and inside of the parentheses, the x is just your variable x. If you have plus some number, h, what that means is that there's going to be a shift or a movement left. It's kind of counterintuitive. You think plus would mean right, but it's actually not, and that's h units. So opposite, if you have a minus and it's inside either absolute value or parentheses, this would be shift to the right, h units. Now, we use h for left and right shift, so the east to west shift. We use k outside of parentheses for an up and down shift. If it's positive, you're going to shift this function up k units, and if it's negative, you're going to shift it down k units. If you have some number that's multiplied by the function, and I'm going to explain this in a little bit, and that number is bigger than 1, that's called a vertical stretch. And we saw that actually on our quiz. We saw it 5 times x. If you have some number multiplied by the function and the function is less than 1, it's actually, to be honest with you, it's not less than 1. It's actually going to be, you actually want to put when it's between 0 and 1. Oopsies. When the a is between 0 and 1, but it can't equal 0 and it can't equal 1. This is a less than sign. So it's 0 is less than the absolute value of a, which is less than 1. That's a vertical shrink or compression. Okay. And lastly, a reflection. If you have the opposite of the function, and that's going to reflect across the x-axis. Reflect across x-axis. Okay, so now on this side, we're going to take a look. So you can pause it if you need it, or if you want to slow it down, however you would like to work that out. Over here, we're going to be looking at the absolute value function, and we're just going to be using this as our transformation base, but you could use it for any function. So a transformation changes the position or size of a figure. Transformations can be applied to parent functions. Use the absolute value example as a function. So the parent function for absolute value, you already know, is f of x equals the absolute value of x. And for the millionth time, I'm going to graph this at 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and opposite direction to show symmetry. And I'm going to draw my lines straight through, extending on forever. Okay, so now we're going to look at this. I'm going to show you that this is where you have your absolute value, and that 2 is inside of the absolute value bars. That is just like the 2 is the H inside of these parentheses. So in order to predict or give a brief description of how this is going to be different from the parent function, now we know that since the plus 2 is there, this function is going to be shifted 2 units to the left. So you could put shifted left 2 units, or shifted left 2. And it's left because of the plus sign. Over here, because it's negative, so it's different from this one, it's the same. Remember, counterintuitive, just like these rules right here, shifted right 2. So if you have the plus or minus some number inside of the parentheses, it's right and left. If it's outside of the parentheses, it's up and down. So this would be, you could say shifted up 2. And that goes with this one right here. And then this one is shifted down 2. And that goes with this row right here. Okay, we just have a few more. This is 2 times the absolute value of x, and this is 1/2 times the absolute value of x. So these are our dilations. And we have a vertical stretch when the absolute value of a is greater than 1, and a vertical shrink or a compression when the absolute value of a is between 0 and 1. So since 2 is greater than 1, you know this is your dilation, or a vertical stretch by a factor of 2. And this, since this value here multiplying by the absolute value of x is between 0 and 1, this is your vertical shrink by a factor of 1/2. Oops. This should say shrink. Okay, last problem. It's the negative times the absolute value of x, which is our reflection down here. So we're reflecting the absolute value of x graph across the x-axis. All right, so that is your notes for the day. And you can always pause it, revisit it, and I will see you tomorrow. Bye-bye.